Okay, so we're going to go over exploring trig functions. Now, I'm going to zoom out a little so that we can see this whole graph. Here you go. And we still have our xy axis. Now, instead of being in degrees, which you guys would have worked in before, we're going to be working in radians, okay? And I think you said you kind of remember the difference between the two. Do you recall what a sine function, how it starts and goes up and down across this type of graph?
I think it starts at the halfway, at 0 or something.
Okay, so at 0 and 0 is where sine will start.
Yeah.
Okay, and now normally when you first would have learned this, you would have gone over it in degrees. Okay, so pi divided by 2 would be considered our 90 degrees.
Yeah.
Pi itself would be considered our 180 degrees. 3 pi over 2 is 270, and we'll go over that too, just in case we forget. And 2 pi is considered 360, like completing an entire circle. Okay, so our sine sinusoidal wave, it goes up from 0 to 1. That would be its highest point. And we're talking about when we have f at x is equal to sine x. So there's been no transformations to this function or anything like that. Okay, and then at 180, it hits 0 again. At 270 or 3 pi over 2, it's at -1. And at 360, it's at 0. So this would be considered the period of the function. Okay, and this pattern repeats. This would just be one period. So what we're going to do is we're going to look at this on an actual XY graph. So I'm going to scroll down a little and zoom in. So what we'll do is we'll see what that actually looks like, just to make sure you recall all these things. Okay, so if we were going in a circle, this would be considered 90 degrees. If we're starting from here and heading up to there, this is known as a 90-degree angle, right? Yeah. So this would be a movement of 90 degrees. This is also the same thing as our pi over 2. Is that familiar to you?
Yeah, I remember this.
Yeah? Okay, so then this is pi, 3 pi over 2.
That's 2 pi.
Yeah, exactly. And then we can continue around in this pattern. And these are related, just like we said above, as 180, 270, and this is technically also 2 pi is 360. Okay, so that's familiar to you?
Yeah.
Okay, good. So we already have that idea. So we go back up to our graph. This is our sine wave, and it's going to continue in this pattern. So it's going to jump up, and then on the way back, it does the exact same pattern. We just have to continue it along. Okay? So this would be our original sine wave. And if we ever get stuck, okay, if you're ever stuck, you can always take out a calculator to get a feel for what these things actually equal. For instance, pi over 2 is also known as our 90 degrees. So right now I'm in degrees, right? Yeah. If I do 90 degrees sine, it gives me 1. I know that that point will be 1. Say I had to find in between that, something like 45. 45 would be halfway here. So 45 degrees sine tells us at 0.7, which is probably about where we estimated this to be. That looks like it's roughly around 0.7. Oh, yeah. So we can go through this if we ever forget what the graph is like. We can continue that pattern. Say we do 180 sine, gives us 0. So we know that the y value, when we plug in the x value at 180, our y value is 0. If we're at 270 sine, gives us -1. So it tells us all of our major points. Okay, and we can continue this pattern. And as we change the function, let's zoom out a little again. As we change the values of this function, we'll be able to move it, and if we ever get confused, we can always plug them into a calculator. Okay, yeah. So the black one is a sine function. We'll do a cosine function. Okay, cosine starts at 1. It's a little different from the sine function. Yeah. Okay, you recall this?
Yeah.
This is all right with you?
Yeah.
Okay, and you know how this pattern continues?
Yeah.
Okay, good. So then what I'm going to do